Hi, and welcome to Car Corner on CCP TV, the educational channel of the Community College of Philadelphia. My name is Richard Saxton. I'm the coordinator of the automotive programs here at the Community College of Philadelphia. In today's episode, you're going to see Dan Reed bring everything to a stop with his discussion on anti-lock brake systems. If you have any questions about the automotive programs at the Community College, please check us out at our website. Thanks, and have a nice day.
Hi, I'm Dan Reed with the Community College of Philadelphia's Automotive Technology program. Welcome to Car Corner. Today, we're going to be talking about the world of brakes. Now, brakes are obviously something that you use to stop your car, so they're quite important, but they also have gone through a few technical changes over the years, mostly involving some of the materials that we make our brake components out of. The actual mechanics of brakes really haven't changed very much, and for most people, in terms of doing things yourself at home, kind of doing a DIY driveway type of job, brakes are something that most people generally feel comfortable tackling themselves. It's not it's not an overly complicated job. Generally, you don't need special tools for it. You can get by with some good hand tools. So working on brakes really isn't very difficult. However, there's a few things that you need to be aware of, and we're going to cover some of those now. First and foremost is, what are the two major components in a modern braking system? Well, we have this large, flat disc shape component here, and this is a brake rotor disc. Now, if you've heard the term disc brakes in a car, that is this component here. It is generally made out of a cast iron, a gray cast metal, and it's then machined. This one is used. The first thing that I get in terms of questions with brakes is a lot of times is, after I wash my car, I get this rusty look on the rotors and they look all nasty. I have really nice shiny wheels and I get this rusty surface on there. Is there anything I can do to prevent that? The answer is no. It's completely normal for brakes to rust after a rainstorm, after you wash a car and the car sits for maybe just an hour. You'll see a light orange coating on the rotors. What can happen is, over time, if the car is really sat for quite some time, even though it's not on the road, that rust will actually attract moisture, and that moisture is going to accumulate and build up as more rust. Now, what happens is that when you go to drive the car after it's been sitting for some time, when this brake pad material, which here's our brake pad right here, our brake pad is made up of different types of compounds. This brake pad material is the friction surface that rides against our brake rotor. The two are sandwiched together, something like that. And what we have is we have a unit called a caliper that pushes down against this brake pad, against the brake rotor surface. That friction between the two components generates heat. It does in fact generate some noise, which is generally the complaint with disc brakes, and it's going to cause a little bit of surface wear as that rust gets basically ground off the surface of the rotor. Now, in terms of brake noise, which is actually the complaint on the vehicle behind us, most brake noise complaints are sometimes normal. They're almost unavoidable. If you have a rainy or wet event like we were just talking about, and your brakes make a little bit of a grinding sound, which can be a little disconcerting, or even a couple squeaks, first couple times in the morning as you're pulling out through a couple stop signs in your neighborhood, that's actually normal. What's not normal is to have the brakes constantly make noise every time you hit the brake pedal, no matter what the condition is. Grinding noise that is consistent, that's a problem. Or if we get a squeak every time we hit the brakes, that's also an indication of problems. So just remember, a squeak a couple times in the morning, grinding sound in the morning, not a problem. Constant squeaking or grinding, that's something that you should definitely take a look at. This is a new brake pad. This is what they look like when they come out of the package. And the thickness of this material right here is really based on whatever the manufacturer wants to see in terms of their engineering. This slot that you see cut through the center here it acts a little bit like a rain gutter, and some brake pads actually have a slot that is maybe in a different direction. Manufacturers try some different shapes with brake pads sometimes to try to actually prevent some of that noise. And in terms of the brake pad design, you'll notice that this one here actually has a little bit of a chamfer cut on it. And that chamfer cut is not put there by the person that installed the brakes. It's actually formed there during the manufacturing process of the brake pad, and it's designed to actually help act as a little bit of a landing pad for some of the debris that might be on our rotor and actually make the brakes a little bit quieter. So that's also the purpose of these slots here in the middle. They act as a gutter. They're going to collect any trash that builds up on the rotor. When you drive through a muddy puddle, mud is going to get could get on the rotor. We want that place to have an exit, so to speak, for that to come through. Some manufacturers also do it for what's known as outgassing. Now, outgassing is a process that when we get these pads very hot, they actually generate a layer of compressible gas. And it's not flammable, but on some older pad designs, this was an issue, and that pad would actually build up this layer of gas and then float against the rotor surface. That would affect its friction ability, would actually increase the stopping distance of the brake system, and by having this slot here, we allow some of those gases to escape as well. So these slots really are kind of multi-purpose. Okay. So in terms of brake pads and what they're made of, if I take a couple different brake pads and I just lay them here, some of these pads, you'll notice that not only the shape, but the actual coloring of the materials is different. Now, brake pads have gone through several generations of different materials, and the different materials are there to increase the wear of the brake pad to make it last longer. Also, noise is the other factor, and heat resistance is another factor. Brakes get very, very hot. Sometimes we're going to actually use organic compounds. You may have heard something called organic brake pads. Walnut shells are actually a major component in some brake pads, along with materials like asbestos, which we still use occasionally in some brake pads. We also use metals such as iron, copper, and brass. And in some really, really high-end brake pads, we'll actually use Kevlar, which is the same material used in bulletproof vests, synthetic carbon fibers, such as what you might find on a racing-type brake pad, and then also some ceramic compounds as well. So really, the wide range of different types of designs that we have for brake pads are really designed for different types of uses. Plan accordingly, really look at how you drive, and then use that as an indicator of what type of brake pads you want to look for when you're replacing them. The brake pads are going to start to wear out. And this one you can see starts to get very, very thin. The pad itself is almost gone, and what we're left with is this surface here on the back, which is called the backing plate. The backing plate of the brake pad is the material that this pad material is bonded to. Now, this type of brake pad is called a bonded brake pad, and it's called a bonded brake pad because this guy, if you notice it has these holes here, this is called a riveted brake pad. Now, these rivet holes in here are the mechanical fasteners that hold the brake pad material to the backing plate. And in the state of Pennsylvania, the state law says that the minimum thickness of a bonded brake pad is 2/32 of an inch, and the minimum thickness of a riveted brake pad is 1/32 of an inch. When it comes to measuring brakes, it is part of the state inspection process, and the way that process occurs is not just a visual inspection. The human eye really can't just eyeball something down to a 32nd of an inch that well. Plus, the state of Pennsylvania actually wants to see a real measurement take place. So what technicians do during a state inspection process is they're going to disassemble one front brake. Now, if you go to a quick oil change place or a place that does a fast tire rotation, we're going to take this rotor right here, and I'm going to take this brake pad as an example. What they might do in terms of a brake measuring process is they're going to use a brake pad thickness gauge set, which is what I have here in my hand. Now, it doesn't take a brain surgeon to use these things, and they're a good, fast visual indicator for the technician to possibly show the customer exactly how thick the brake pads are. Obviously, up here on the green scale, we have thicknesses up to 12 millimeters, which is about 47 thousandths of an inch. And then we have some yellow, which is, your brakes are getting a little low there. It's time to think about replacing them. And they're going to go from anywhere between 6 and 4 millimeters. And then down here, when we have the red zone, this is obviously it's time for new brakes. You still have brakes functioning on your car, but they're not safe. Now the reason why we don't want this to come all the way down to this backing pad material, the backing plate of the pad, is because the backing plate will then contact the rotor, and it's going to actually start to grind into the rotor surface. First, when we take our brake pad measuring gauge, I'm going to take a gauge and I'm going to slip this in between the brake pad and the rotor. I'll say, okay, well that guy has a little bit of clearance. We'll go here. I'll slide this guy in right here. Nope, that one doesn't fit. Take this guy in, and right there, that guy fits. I don't have a lot of wiggle room, so therefore this brake has 10 millimeters or roughly 40 thousandths of an inch. So it's good, okay? If I replace this with a brake pad that is much thinner in terms of its material, I'm going to put that guy on there, and immediately the surface is much, much lower. I can't fit one of these thick green gauges in here anymore. I have to come down to a much thinner size. Oh, that yellow guy doesn't even fit, so I'm into the red zone right here, and get my last gauge, and the last gauge just fits in there just like that. So it's a very fast indicator for when you need brakes. Now, the other indicator that we have is for the customer. This little metal tang on the back of the brake pad right here, this is called a squealer. And what happens is as the brake pad wears, ultimately this metal surface goes against the rotor and it's going to vibrate. That vibration is going to come out as a frequency, a high-pitched squeal that we hear. And my apologies, but this is the sound. That little high-pitched squeal you hear. When you hear that sound every time you hit the brakes, it means it's time for brake pads. In terms of what the technician has to do when they're actually doing the state inspection rather than just a quick inspection, is they're going to have to use a tool like this. This is what the state of Pennsylvania wants us to use as for a state inspection tool. And this is actually requires us to physically remove the pad. Now, physically removing the pad is truly a good way to do a brake inspection because I would miss something like this. If this pad was face down, I wouldn't be able to see all these heat cracks. Now, these heat cracks are going to get worse and worse, and the pad material may actually start to fracture and fall apart on the brake rotor. If this guy is pointed face down and I'm doing my brake inspection with my go, no-go tool, this guy may fit in here just fine, but the fact is until I actually remove this and visually inspect it, I can't see the problem. So let me show you how to use the proper state inspection tool. What we're going to do is we're going to take a brake pad, and we'll take this guy right here, and I'm going to put this tool right there against the backing plate, and there's a needle right there. I'm going to take that needle and I'm going to position it on the zero. So that's my 0 point of the thickness of the brake pad. In other words, that's the thinnest the brake pad can get. This is a bonded brake pad, so I'm allowed 2/32 of an inch. If I pull this tool back, you'll see that that needle moves, and then I'm going to put this pincher on the actual brake pad material, and now my pointer is pointed in between 3 and 4. I generally go with the lower number. So this brake pad is at 3/32. The scary thing is technically this brake pad does in fact pass inspection, but if this car rolled into my shop, you look at the thickness of this brake pad versus what we generally have for a new brake pad, and while the pads themselves are not the same size, the new brake pad material is obviously much thicker. That thickness is going to help transfer heat better. It's going to reduce the stopping distance and basically give you overall braking ability. Whereas this guy, it's really 1/32 away from just passing inspection. And really, if I had the brake pads out and in my hand, I'd probably just make a phone call to the parts department and I'd go ahead and I'd order a set of brakes. Let's take a look at some brake rotors that I have over on the bench, and we'll get these pads cleaned up. So we know that the pads go up against the rotor. We know that they're made out of gray cast iron. We know that they rust, and we know why they rust, but the fact is why would we ever replace them? Well, there's a couple reasons. Rotors are a wear item. While they don't wear out at the same rate as the softer brake pad material, The fact is there is a lot of pressure, a lot of heat, and a lot of friction applied to this surface over the lifetime of the car. Generally speaking, most shops strongly recommend, as do I, that if you're going to replace the brake pads, it's probably a good idea to go through a process known as remachining the rotors. The question is are they actually thick enough to be machined? Now there's two types of brake rotors. We have what's known as a vented rotor, which actually has these air vents through the center of it. The vents help aid in cooling the rotor. The other thing is if this rotor actually gets too hot, what will happen is it will transfer its heat to the pads, and then we get something known as brake fade. Brake fade occurs to most people while you're driving down a mountain road. If you ride your brakes for too long, you overheat the brakes, and the brakes actually start to lose some of their coefficient of friction properties, and they don't get sticky. They actually get less sticky, and consequently, the harder you press on the brake pedal, the worse they work. That's not the ideal situation you want to have happen with your brakes, and so we came up with vented brakes. Now, the earlier rotors, before we had vented rotors, were what's known as a solid rotor. This is actually a modern solid rotor off the rear of a car. Most cars that have four-wheel disc brakes are going to have solid rear rotors and vented front rotors. Now, as a personal rule, I find these solid rotors very difficult to work with in terms of trying to resurface them without having them generate a lot of noise. So most shops will actually say, you know what, these rotors are solid, we can't cut them, we just go ahead and replace them. And in my book, that's okay. Unfortunately, there isn't too much you can do about the actual machining process of a lot of these solid rotors. They can be very difficult to work with. However, there's much more mass with these vented rotors, and they are a little easier to work with. And what we can do is, if we are going to determine if we can machine it, we're going to actually have to measure the thickness of the rotor overall. Now, some rotors, this one in particular, are going to have a thickness specification, and what the technician is going to do is they're going to use a tool called a brake caliper micrometer. Now this is a really nice digital one, and what we do with this is we basically open it up, and I'm going to position it around the rotor, and I get my measurement. 0.979, 979 thousandths of an inch. According to the manufacturer spec for this, I have 970 thousandths of an inch room to play with. So that gives me about roughly 5 thousandths of an inch to cut off the rotor total. Now that means I have a little more than 2 thousandths of an inch to cut off on each side. To put that in perspective, a sheet of paper is 4 thousandths of an inch. I really would not be able to remachine this rotor safely because it's almost at its minimum limit, which is why we have it here in the shop and not on somebody's car. I have a couple rotors here that are not so good. Believe it or not, this piece actually came off somebody's car. And if you're wondering what happened to the middle section where the wheel bolts to, well, it actually separated from this outer part. Now the outer part of this was my friction surface where the brake pad would ride. These lines on the inside here are the actual vents on the inside of this rotor. This rotor was actually machined in half on the car because the people never ever changed their brake pads. They waited for them to get to this metal to metal condition, and instead of the brake pad wearing, the rotor actually started to wear. So brake calipers, what they do is they are the hydraulic component of the brake system. This is a typical brake caliper. It's fairly small. It's for a smaller vehicle. This is what's known as a floating type caliper. And it's called a floating caliper because it has these two sliding pins, which I'll get to in a minute. On the back side of the caliper, right here, we have when you step on the brake pedal, fluid comes in through here and pushes an internal piston back. And then we have this guy on the back here. This is actually our bleed screw. This is the service point to remove brake fluid from the entire brake system. So the reason why calipers fail is because they can develop a leak on the internals of the caliper themselves. Calipers are going to have to be replaced for one of two reasons. They either seize internally. Sometimes these slide pins actually can seize so badly that they literally destroy the caliper. The piston on the inside can seize, or we can develop a hydraulic leak on the inside. As the system works, Hydraulic fluid is driven in from the backside of the caliper. It pushes this piston out. Now, we normally have a brake pad that clips in to the piston side, and then another brake pad that's going to sit on the opposite side of our brake pad. Now, these sliding tabs here on the caliper, these are what give our caliper what's known as caliper action. If this caliper were fixed and it could not slide on these pivot points, the hydraulic pressure would drive this brake pad out, and our rotor sits in between here. As that hydraulic pressure drove that pad out, only the inboard side of the rotor, the side towards the inside of the car where the caliper is, would get any hydraulic pressure. We want the full surface, both sides of the rotor, to both get brake pad effort pushed against them to slow the car down to increase our friction, to get the car to slow down. So what happens is as this piston is driven outward, it actually causes this pad to pull in, and that happens because as this pad is driven out, it actually pulls this entire caliper inward. So if you can imagine, as this guy's driven out, this pad, this caliper is actually sliding this way. Now, my hand here that would be attached to this would actually be the steering knuckle of the car, so the whole caliper floats, hence the term floating caliper. It's this floating action that as it pulls back is going to actually cause this pad, the outboard pad, to also push against the outside of the rotor. So what happens is for a brief second, the inboard pad makes contact, and as soon as it makes contact, the outboard pad is pulled inward as well, and what we get is the squeezing action that occurs and actually creates our friction with the pads. Lots of heat, lots of friction, slows the car down. All right? That's how all calipers basically work. This is the most simplest type of caliper there is. And when we do the car behind me, we'll go through this pad replacement procedure up close. In terms of these slides, if we have to replace them on the car, what these are is they have a small bushing on the inside, which is generally chrome plated, some type of durable wear metal, and then we have these rubber boots. Now the rubber boots on the actual caliper itself, if they're dry rotted or cracked, they have to be replaced. If they're not dry rotted or cracked, you still want to inspect them. And what we have is we have a special silicone lubricant called caliper slide grease or brake caliper lubricant. Now this caliper lubricant is not for the entire caliper surface. It's not for everything that goes against the brakes. It's really only made to go against the actual caliper slide pins here. So if we had to lube these up, what we would do is we'd take our slide grease out and get this guy started and positioned on the way in here, and I would pull this out, pop this guy in here like so, and I would pull this back, and I would put just a little bit of my caliper slide grease. This is some really goopy stuff. I would just take that and I would just put a little bit on there, about that much. And then what I'm going to do is as I put this in, I'm going to kind of swirl it around, move it up and down, back and forth a little bit, and make sure that that pin is well lubricated. I'm going to do the same thing on the opposite side. I'm going to flip the caliper upside down and put a little bit of grease on the inside there and make sure that I don't have any excess residue around the outside of this. And then my caliper can slide freely. What happens with a lot of brake systems as they wear is those caliper slides will freeze up due to lack of lubrication in the long term. Lots of heat cycles, lots of salt water from wintertime driving. It's going to dry that lubricant out. What happens is you know that you have this occurring if these pins seize because the inboard pad, the pad up against the caliper side, is gone. It's completely worn out. The outboard pad looks brand new. Well, what that means is that we had that inboard piston doing all the hydraulic work, pushing up against the rotor. This outboard pad, it didn't work because these pins couldn't slide. This is called a fixed caliper, and this is known as a 4-piston fixed caliper. This type of brake caliper has 1, 2, I'm going to flip it upside down, 3, 4 pistons. This type of caliper does not float. The pads sit on either side here. The rotor sits here in the center of the slot, and the entire caliper itself is bolted to the steering knuckle. Now this type of setup delivers much more braking power, and you're going to see this on some high performance cars. This is a difficult assembly to work with rather than the floating caliper. And what we're going to see here is that this guy has 4 bolts on the back side. Now these 4 bolts, when most people go to take a brake job apart, they think that these 4 bolts are somehow the caliper slides used to disassemble the brake caliper from the car. If you take out these 4 bolts, there's a seam on this caliper, and fluid travels from the back side of the hydraulic system through this through a chamber on the inside into these pistons over here. If you take these 4 bolts out, you're literally going to split the caliper in half and start leaking hydraulic fluid. You don't want that to happen, not when you were just in the middle of replacing some pads and rotors. So if you have a 4-piston caliper setup, make sure you double check the manufacturer's instructions and you only take out the 2 large bolts that hold the caliper to the steering knuckle. Okay. Another type of caliper, briefly, this is a dual piston sliding caliper. This is a lightweight alloy, very lightweight, far better than some of the cast iron ones. They make this out of lightweight material because brake calipers, if they're heavy, they're going to slow down the action of the wheels. That's going to affect the overall handling of the car. 2 pistons, basically it's a floating caliper with 2 pistons, and I have 1 hydraulic port and a bleeder on this. And really not difficult to work with. You just use it like a regular fixed caliper, I'm sorry, a floating caliper, and really doesn't need any special service notes, okay? The last caliper that we have is a type of floating caliper, has the slide pins on it, and you'll notice that the piston is an odd shape. Now this is what's known as a rear disc brake integrated, parking brake integrated caliper. This type of caliper has a lever on the back side here, and when you pull up on the parking brake or step on the parking brakes, this lever is retracted, it's pulled back. Well, what that actually does is that is retracted back, is that's going to cause the piston on the inside here to extend outward. Every time you hit the parking brakes, you're manually actuating the piston on the rear brakes. Now normally, under normal braking with what is known as the service brake or the brake pedal in the car, hydraulic fluid is what's actuating the cylinder, so the caliper. So this type of brake setup can actually be actuated by a cable, and it can also be actuated by a piston as well. The thing you need to be aware of this type of brake caliper assembly is that in order to push this piston back for service, you can't just push the piston back. You actually have to turn the piston with a special retraction tool. We're going to get to the vehicle behind us here and start to disassemble its noisy brakes. So what we're going to do is we're going to take the brake system apart, clean everything, lubricate it, machine the rotors. I do have new pads for it, and I'll show you a couple tips as we go through and try to prevent this brake noise. So the brake noise on this car is consistent, like we talked about earlier, and it's a very loud, high-pitched noise. You can literally hear it with the windows rolled up in the car, and it does it every single time we hit the brakes. So what we're going to do is we're going to start by taking our wheel off. Having a nice upscale wheel here, what we have is we have these protective sleeves over our wheel sockets. And these protective sleeves, what they're going to do is when we put this inside the bolt hole here, we're not going to scuff up the inside of the wheel. Now that might seem like a pretty minor thing to worry about, but in reality, with an expensive set of wheels and tires, you don't want to damage them. So we're going to be careful, and we're going to take our wheel and tire off. Okay, there we go. All right, so here is our brake rotor setup. Now, we can see our rotor. This is my brake pad caliper that we talked about earlier. Pads are on the inside, and on the back side here I have some bolts that hold this unit together. Now, like I talked about before, there are some bolts namely these ones down here and here, that we're not actually going to remove. Now this one has some rubber caps on the back. I'm going to pop those rubber caps off and then take off these larger bolts, and that's how we're going to actually disassemble this brake setup. Now, what this car has is a retaining bolt that's a Torx bit. Now what this does is, in order to take the rotor off from the hub, we have to loosen this little teeny tiny screw. And the trick is they tend to strip out. And this is really common on a lot of European cars because we have wheel bolts instead of studs. If you change a tire on the side of the road, you wouldn't want the rotor to spin around and lose sight of the holes in the wheel hub that the actual wheel bolts bolt to. So this little screw bolt is a retainer that keeps the rotor clocked in a specific position. The tricky thing is they tend to strip out. So I'm going to put a tool called an impact screwdriver on here, and when I whack this, it's going to actually act as an impact gun and try to shock the bolt loose. I'll make sure that we're going in the right direction here, and I'll give this a couple taps. There we go, and that guy comes right out. Now, if you run into these and they get stuck, you can see the rust on the inside of this one. You can drill them out. You can hit them with a regular, conventional metal drill bit, and in the process, you're going to actually destroy the screw. You could then extract the center out and replace it. Now, if it is destroyed beyond recognition, fact is it's actually not critical to the operation of the brakes. It's just a convenience feature, and you can actually skate along without it. So now that that guy's out of the way, manufacturer has us remove this large metal retaining clip that is a silencer for our brake system, and we'll loosen this guy up. The directions actually do say to use a screwdriver. Normally I'm not a fan of using a screwdriver. I prefer to use a pry bar. And we'll loosen this guy up and pry him out of the way. Walk this piece out. Now this retaining clip, this is an important spring that actually helps hold the brake pads in place. Without this guy, the pads can kind of shift around a little bit. This is a big, thick piece of spring steel, and we have to make sure that we put this back in the right position. I'm also going to add a little bit of lubrication here where it slides into its tabs and make sure that those mounting surfaces are clean without any rust or debris on them. And that in itself can actually create the noise that we're trying to combat, but we're going to do the full brake job on this, so we'll keep going. The next thing I'm going to do is on the inside here, there are 2 large bolts, and then there are 2 rubber caps. I'm going to pry these rubber caps off. There's one rubber cap, and there's another rubber cap up here. And the inside of these, there are Allen screws. Now the Allen screws on the inside are protected by these rubber caps to keep debris out of the Allen screws. If we have Allen screws, it's a good idea to make sure that your Allen screw head of your tool is clean and square. If these things are kind of rounded off or rusted or don't really seem to fit very well, you're going to have a serious problem in trying to remove these bolts. You can actually strip out the heads of the bolts, and unlike this guy that I said you could just go ahead and drill out and forget about, these guys you can't. So we'll be careful with these. Make sure that we're going in the right direction and make sure that my tool is firmly seated on the inside. I'm going in the right direction, and then I can loosen them up. There's one, and 2. Here's the other one down here. Now once I get these guys loose, I'm going to want to be careful because this whole outer caliper bracket is now loose. I don't want it to come smashing to the ground. And I want to be very careful to make sure that I see how everything goes together. All right, and then my brake rotor is loose. And now I've got just a couple more large fasteners to remove, and then the whole unit can come apart. You know, brakes are pretty simple. They generally don't have a whole lot of hardware holding them together, and that's why there's so many brake and muffler shops in existence, because really, you don't really need that many special tools to actually work on a set of brakes. Let's make sure that that guy is seated. I'm going to take a wheel bolt, put that right back in there. Just hold that disc in place for now. Make sure it doesn't come crashing to the floor. Okay, now I got to take out these two large bolts. And for that I need to use a little air-powered persuasion. And that's the top bolt. And then there's a bottom bolt. But before I do that, up here there is a connector for a brake pad wear sensor. Now, when I go to take this off, I want to make sure that I don't damage any hoses or wiring. So I want to be really, really careful about this and make sure that when I move this, it goes back in exactly the same spot where it is, where it was before. So this connector is on the top here. I have to dislodge it. Then I have to use a little persuasion here to pull this apart. Might need a pick or something to dislodge this connector. There we go. Got that apart finally. And now what I'm going to do is I'm going to take out the bottom bolt, and then I'm going to shift this whole caliper up here on top of the brake assembly. Shift this whole unit up carefully, because it is a heavy piece. Position it right there for now. And what you never want to do is you never ever want to let the caliper hang by any of its wiring or anything like that. So what I'm going to do is I'm going to take this assembly apart. I'm going to flip it upside down and take a look at it here. This is my outboard brake pad. This is the carrier assembly. This is the inboard brake pad. I'm going to use a little screwdriver to pop this guy out. Just like so. Okay. This is my caliper carrier. We'll take a look at that in a second. And this is my inboard brake pad. Now this wire hanging off here, this is our brake pad sensor wire. In terms of this guy, this is our caliper. And what I have to do now is I have to push this piston back this way so I have room for my new brake pads. So what I have there is a tool. That's going to allow me to do that. The other thing is while I walk over to the other bench here in a couple minutes, I'm going to take a piece of wire, just a piece of coat hanger, and clip this around here to support my caliper so that way it can't fall anywhere while I'm working. It's a good idea to use a piece of wire. A lot of times I'll actually just lay this on top of a suspension component, but the fact is I don't want this to fall, especially not while I'm doing it on camera. So I have my caliper here. Take this guy, and we're going to push this piston back. Now the other thing I've done already is, off camera, I've opened up the brake master cylinder, which we've talked about in past episodes. And I have opened it up a little bit, and I've taken some of the fluid out. So when I push this piston back, I'm sending fluid up through the brake system. I don't want to rupture and overfill my master cylinder at this point. So yeah, we're good. Guy's good and flat. Okay, so now that I have these pretty much prepped, what I'm going to do is I'm going to pop this brake rotor off, and we're going to go and I'm going to show you what's involved with cutting a brake rotor. So we're here, a little bit of a change of scene. This is another part of the shop which you have not seen before until today. This is our brake lathe room. This is a big piece of equipment here, is a metal cutting lathe specifically designed to cut brake rotors. And what we have is we have two large sharp carbide tool steel bits that are going to machine the rotor surface. Now, you're going to see this process, and you're going to see what the rotor looks like before, during the cut, and then after the cut. But hopefully it'll give you a good idea of what's involved in turning or machining a rotor. So I'm going to start with our rotor here. This is just a rotor, and I'm going to position it here on the arbor. And then I'm going to mount the rotor to the lathe using some specialized adapters. And we'll get this set up here, and then we'll get cutting. Okay, so I'm putting these adapters on and putting this reversed hand thread nut on. And this is going to mount the rotor to the lathe. Tighten this down. And what I'm going to do is bring these cutting tools over a little bit, center them up with my rotor. And I have to install something called a silencer band around the brake rotor itself. If I don't do this, what happens is the rotor's going to actually vibrate, and as it does, the cutting bits are going to act like the needle of a record. They're going to create a vibration that's actually going to cause a rough surface on the rotor. When it goes back on the car, it's going to make a terrible sound. So we're going to make sure that we put our silencer band on here. And of course I have to remember to take this off once I put the vehicle back into service. All right, make sure that is on there. And I'm going to turn my lathe on. Make sure that everything looks okay. And I'm going to lock my cutting bits down. I'm going to bring my lathe in. I'm going to take what's known as a scratch cut. I'm going to back this off a little bit, do a little bit of an adjustment. It's really important to make sure that the rotor is centered properly on the arbor. If not, you'll actually cut a warped pattern into the rotor, and instead of making things better, you'll actually make them worse, and we don't want that to happen. Just going to do a quick inspection of those two scratch cuts I made. Make sure that they are where they belong. And they are parallel to each other right there. And that's what I want to see. So I'm ready to set this up to start cutting. I'm going to bring the inside bit in, wind in my rotor. And I'm just going to make these bits just make contact. I'm going to zero out these measuring knobs. And I'm going to wind this in. Now when I do this, you're going to see rust and debris kind of shooting off this thing. That's normal. You actually want to see that. That's us removing some of this old material off the rotor before we start cutting. Okay. I'm going to bring my bits in. Just a hair. I'm going to flick a lever on the back of the machine, and it's going to draw these bits backwards, and as it does, you're going to see a fresh metal surface be cut into the brake rotor. Now you see that gray shiny, that gray satin part, that's fresh metal. The duller part here on the outside, that's actually brake pad material that's been embedded into the rotor. And I want to make sure that I cut both sides at the same time. So I'm going to look at this side as well, and I'm getting a pretty good cut so far. And you can see that that made pretty quick work of that old surface. Now that fast cut is actually, this is actually a fairly rough surface now. So what I have to do is I have to go back and do a process called a slow cut. Now with the slow cut, it's the same exact process. I'm going to move the bits in a little more, but I'm going to cut them at a much slower rate. That's going to give me a different finish. It's going to give me almost my final finish and really make this rotor smooth and parallel. Now the slow cut gets its name because the cutting bits are moving much slower. And at this point, a technician typically is going to go, walk away from the machine, go do another job, finish another part on the car, actually go have lunch. So the fact is this process on some large rotors can take some time, so we'll just have to wait. And I got a good smooth finish on both sides of this. Okay, so I'm going to power this guy off. Carefully move these back. And at this point, I could almost just about take this over to the car. But I'm going to pop off the silencer band. And what I'm going to do is a process called a non-directional swirl finish, which if I were to take the rotor and put this on the car right now, there is still a groove cut into this rotor, and there's a chance that the pads would walk on that groove. So what I have is I have a burnishing tool, which is this guy right here, hooked up to a low RPM air drill. I'm going to turn the lathe on and I'm going to hit this on both sides, and you're going to see this smooth surface get a little kind of sketchy and rough. That's actually my finished surface at that point. And when I'm done that, we'll take it off and put it on the car. There's one side and here's the other. Okay, and now that smooth satin finish is roughed up in many different directions. So I have my non-directional swirl finish. We'll wipe this down with a little bit of brake clean and we'll get it over on the car. So we've got our rotors nicely fresh machined from our machine room. I am holding it with a towel. Even though my gloves are fairly clean, I want to make sure I don't get any grease or oil whatsoever on the rotor surface. If I do, I'm going to have to go ahead and hit them with some brakes parts cleaner on a clean rag before I put the brake pads anywhere near them. So this is our hub. Now this is where our brake rotor is going to mount up against to, and you can see that it's obviously rusty. Now this is pretty typical with most vehicles with any type of mileage on them. This car is about 68,000 miles on it. And the hub itself has to be a flat surface that the rotor is going to bolt up to. The rust is going to act like an imperfect surface. When we start to compress our calipers down, there's a possibility that this rust could induce a vibration in our rotor. That vibration could be transferred to other components, and it would basically act like a tuning fork and make a high-pitched sound. So we're going to take an air-powered die grinder with an abrasive wheel, and we're going to grind this surface smooth. Now I'm just going to kind of dress this up. I'm not real concerned about this inner surface here, but more so this outer surface and this hub where the rotor actually attaches to. Now, that's looking a lot better. What I'm going to do with it is I'm going to take a product called anti-seize lubricant, and I'm going to just put a little bit around this edge. Now what that's going to do is that's going to prevent corrosion occurring later down the road as the car's aging, goes through some heat cycles with some moisture, and we're not going to get this rust buildup again. So I'm just going to put a little bit on here. I'm not going to go crazy with this, and I really don't want to get this into the bolt holes where our wheel bolts go through, but I certainly don't want to put anti-seize compound on the things that hold our wheel and tire together. What I am going to do though is this is our little indexing screw. If you remember that guy that goes in there, I'm going to put some right in there so that way the next person that does the brake job, which could be me, I don't have to fight that screw out like I talked about earlier. And this is our brake pad with our sensor wire, and then this is one of our outboard brake pads. Now the new brake pads, when you work, you want to make sure that they are the same shape and have roughly the same type of dimensions. Now the fact that these shims are different is not a big deal. It's not a big worry. I have this anti-rattle clip here. It's pretty solid. My connector wire is the same size. It's the same type of connector that I have there, so I know my brake pad warning light is going to function. But the actual thickness of the pads is pretty significant. The pads we're replacing are at about 50% life, so we're not wasting money, but at the same time we're doing an okay thing. Now I'm putting these down on a clean surface because I want absolutely no grease or oil contamination migrating into the brake pads. Again, just like our rotor, if we get any type of material on here that's going to act as a friction modifier, it's bad news. So we want to make sure that our brake pads stay clean and dry without getting anything on there. If we do get grease or oil on them, unlike the rotor, this isn't going to help. The brake clean will not help. So I really, really have to keep these clean and dry. And what we're going to do is we're going to put a product on the back of these pads called anti-squeal compound or disc brake quiet. And I'm not going to put a whole lot on here, just a little bit of this product goes a long way. You'll see people use this sometimes and they will go hog wild with it, and you really don't want to do that. That is more than enough that I need. Manufacturer says that has to sit for 10 minutes before we set our brakes together. So what I'm going to do is I'm going to set these aside while that sets up, and I have another piece to clean over here. This is my caliper carrier bracket, and what I want to do with this is these are the slide points where my brake shoes are going to ride. I want to take a nice stainless brush and brush off all that old nasty brake dust. All right, so that guy is pretty well cleaned up. Now on this caliper carrier bracket, if I see any type of damage, if there's any types of notches or grooves or anything in here, I'm going to actually have to replace the bracket. Now this one is fine, but what this manufacturer wants us to do is they want us to take a little bit of the anti-seize compound, and I just have to use a little bit here. They want us to actually coat these surfaces where the brake pads are going to make contact. So I'm just going to dab a little bit on there. So that's good to go. So now that we got everything lubed up and cleaned up, we can go ahead and start by putting our rotor back on the car. So I'm going to take my impact screwdriver and my little rotor hold down screw. I'm going to start with that. Okay, so that is firmly seated. And now the rotor is on there. It's not going to fall off the car, so we're in good shape. I can start now by putting my caliper carrier back on the car that I have cleaned up. And we'll disconnect our wire we have holding up our caliper here. Swing this guy around. A little easier for us to see. And I'm going to take my caliper carrier. There we go. Guy goes on like that. Now before I go ahead and do this, I think what I'm going to try to do is I'm going to try to fit my pads in. Make sure that everything's going to line up, taking a good look at it. So before I took this apart, that brake sensor wire was in between this bracket and this top piece of the material of the caliper carrier right here. Kind of that sensor wire snaked in between these two parts. So I have to be really careful when I put this back together to make note of that. I don't want to put this together and then say, oh, I can't run the wire, I'll just snip it or forget about it. I wouldn't ever want to do that. So I really want to take my time and make sure I got this all lined up. So let's see here. I'm going to take my bracket and mount my bracket up. And before I do that, I'm going to take these two big old big old caliper bracket bolts that I had to use that air gun to take out last time. What I'm going to do with these this time is I'm going to actually coat these with a little bit of thread locker compound, and I will make sure that these guys are nice and corrosion proofed and don't rattle loose, and there's no vibration occurring. So I'll put that on there real nice. Take my caliper mounting bracket, start to line this guy back up. Okay, and I'm going to hand thread my fasteners. Okay, I'm going to take my outboard pad, which has been setting up long enough. I'm going to sit this guy right in here like so. Make sure that everything is going to line up nice and flat, and we're good. Then I'm going to take my inboard pad with that wire and carefully connect this to the caliper. There we go. There we go. And that guy's going to slide in there like that. And then I have to make sure that my wire is looped in between there. I'm going to take this whole bracket and set it on top here. I have to make sure I don't pinch or crush this wire when I do that. So I'm going to disconnect my caliper holder here, move that out of the way. And do this, make sure that my brake hose is not overly twisted any one particular direction. I'm then going to run my connector back on from my brake warning wire and make sure that it's secured back in its housing where it belongs. Then we'll push our caliper guide pins back in. All right, and we'll start to tighten these back together. Now, if you notice, this whole assembly appears very loose and wobbly. And what I have to do is, before I go out for my test drive, after I put my wheels back on and everything's clean and torqued, what I'm going to have to do is I'm going to have to gently pump up the brakes. What that's going to do is that's going to draw this whole assembly together and in the process firm up the brake pedal. Anytime you do any type of brake work, you really want to make sure that your brakes are in fact working before you put the car in drive and pull out of the garage. All right, there's those. And I don't want to forget my little rubber caps to keep dirt out of the back of those Allen bolts. Okay, and then we'll torque those larger bolts. I'm going to get this one down here. And this is my larger torque wrench for those big bolts in the back. And we always want to make sure that we follow the proper torque, and we always listen to the manufacturers and engineers' requirements for how tight bolts should be. We don't want to strip anything out. We don't want to leave anything too loose because that's what causes vibration and noise. There's that one. Okay. So at this point, I'm going to get the other side done, and we'll put our wheel and tire back on here and torque it down. Go for a road test, and I have a very good feeling now that everything's done right that our noise is going to be gone. I'm Dan Reed. Thanks for watching Car Corner. Drive safely. And remember, kids, make sure you drink your Never Seas, because if you don't, you'll never seize again.